Okay, we are in advanced math trig honors mods 2, 3, and 4. Hope you had a great weekend. Welcome back, new week. Getting close to the end of this chapter, not quite finished yet. Today, Monday, April 20th. So top left corner of your notes for 2020, Monday, April 20th. The title just says more logarithmic equations. If you think back to Friday, we were on the worksheet that I had attached to Schoology. I believe there were 20 questions on that. On Friday in class, I did 1, 3, 5, 7, and 9. Your homework was 2, 4, 6, 8, and 10. Today, on Monday the 20th, we're going to finish that worksheet. So calculator out for sure. And then refer to that worksheet whether you've printed it out or not. But I am going to now do 11, 13, 15, 17, and 19. So your homework's going to be 12 to 20 even. Okay? So I'm going to do 5. You're going to do 5. Stay with me. Think with me. Don't just copy. Don't rush ahead of me and try these on your own. There's a couple little tricky things on a couple of them that you really got to watch for. But again, we're solving logarithmic equations. Of course, these are all equations that we're trying to solve for the letter x, and they're all going to have a logarithm on one side or the other or both. Okay? Let's pick up where we left off, number 11. I'm looking at this. Guys, things you got to think and notice things and then kind of talk to yourself. I notice that there's only one log in this problem. As soon as you see one log, your brain goes to the name Ben, correct? Because every time we saw a log, down here we have a base. On the other side of the equal sign is our exponent. And over on the left of the equal sign next to the word log is our final number. So bottom line here, because it's a log and you don't see a base, it's understood to be a base 10, right? A common log. So if I follow the bouncing pen here, I have a base, an exponent, a final number. My base is 10. My exponent is always the number on the right side or the other side of the equal sign, so that's a 2. Equals, and then on that side of the equal sign is always my final number, in this case, x minus 3. So, oh my goodness, it can't get much simpler than this. Obviously, if you take 10 and square it, okay, focus, that's 100, equals x minus 3. I'm not even going to need a calculator. My job is to get x by itself, correct? So shove over, add over the 3, and x equals 100 plus the 3. Oh my gosh, my missing number is 103. I think if you just looked at the original problem, you could have figured that out yourself. Think about it. If I take 103 and plug it in for x, isn't 103 minus 3 100? So if my base is 10 and I square it, I end up with 100. So it's pretty obvious, even checking it when we're done, that 103 makes perfect sense for the answer to that question. Okay? 13. Log of x plus 4 minus the log of x equals the log of x plus 2. Okay, remember we condensed and expanded logarithms. Shouldn't this left side get condensed? That's what I notice. That's what I recognize because I've got the log of m minus the log of n. Okay, remember remember the quotient rule as we called it? The log of m over n equals log m minus log n. So guys, this left side of the equal sign, if I condense it, I've got the log of x plus 4 over, because that's a minus sign, I make it a division problem and put x plus 4 over x equals the log of x plus 2. So far, so good. Now, good news here. We have not seen this happen yet. But if there's so many logs involved in the original equation that you end up with a log on the left and a log on the right, and the base of the left log is the same as the base of the right log, oh my gosh, the logs disappear and cancel each other out. Okay, now that's true when the base of the log on the left matches the base of the log on the right. So those logs can be disregarded. So really we end up with x plus 4 over x equals x plus 2. Obviously that's understood to be over 1, which I'm going to point out because to solve any proportion, we're thinking let's cross multiply. Agreed? So when I take x times that entire numerator, you agree that's going to be x squared plus 2x equals, and then 1 times x plus 4 is x plus 4. I'm just cross multiplying. I end up with an equation that no longer has a log in it. Now this is a what? A quadratic equation, right? You've been trained for the last 2 years. Take everything and move it all over to the same side of the equal sign. Get it in quote standard form. So I've got x squared. Now that's a plus 2x, but aren't I minusing over an x? So that'll be plus x, and then minus 4 equals 0. Unfortunately, I don't think this is going to factor, is it? Because there's no way you can get factors of 4 that add up to 1. So I'm going to have to use the quadratic formula. If your calculator has the ability to just type in A, B, and C and use the quadratic formula, obviously A is 1, B is 1, C is negative 4. If I use the quadratic formula by hand real quick, in case your calculator doesn't possess that ability, we're supposed to get 2 answers here. So negative B would be negative 1 plus or minus square root. B squared would be 1. Minus 4 times 1 times negative 4, stay with me, is really plus 16 all over 2a, which is 2. Obviously, that's the square root of 17. So on my calculator, when I hit the square root of 17, I get 4.1. So I've got negative 1 plus or minus 4.1 all over 2, giving me 2 answers of, now, negative 1 plus 4.1 would be what? 3.1 divided by 2. So I'm going to divide that on my calculator. 3.1 divided by 2, 1.55. And guys, notice negative 1 minus 4.1 is going to produce a negative answer of some kind. I don't really care what that negative answer is because look, if I take it and I plugged it in the original problem, you can never have the log of a negative number. You can't have a log of a negative next to it, right? Because you can't take a base of 10, raise it to some power, and have it turn into a negative number. So no matter what the negative answer is, it's irrelevant. And it looks like 1.55 is my final answer. So it gets a little yucky at the end, depending on the type of equation you end up solving. Okay, block 3, which is number 15 on our worksheet. Interesting problem here. Watch this. Oh, look at the left side. Similar to the last problem we did, I've got the log of m plus the log of n. Remember the product rule for logarithms? The log of m times n equaled the log of m plus the log of n. So this sum of 2 logs can change into the log of a product. Agreed? So I'm going to put x times x squared minus 8. That's what we did when we condensed our logarithms. Equals ln of 8x. Uh-oh, good news. Even though it looked a little scary, I have an ln on the left and an ln on the right. If you have a logarithm on both sides and the base of one matches the base of the other, which of course they do because they're both natural logs, they cancel each other out. So really, I end up distributing here and getting x cubed minus 8x equals 8x. Oh, so now what would I do? Guys, agreed that I'm going to take this 8x and shove it over to the left side, giving me x cubed minus 16x equals 0. Now what? Don't they have an x in common? I factor out an x, leaving me with x squared minus 16. That's, of course, the difference of two squares when you factor it, agreed? So I have x times x plus 4 times x minus 4 equals 0. Since they're all dot connected, I do the old let's split them all apart and set them all equal to 0 trick. I'm going to end up with x equals 0, x plus 4 equals 0, x minus 4 equals 0. So my answers are 0, -4, and 4. Notice, however, -4 doesn't work because when I plug it in for the initial ln of x, I can't have the log of a negative number. That answer's no good. 0, if I plug it in there, is okay because ln of 0 is actually what? Think about it. Isn't that 1? Actually, it's not possible, is it? If my base is an e, is there any way I can raise that to a power and have it turn into 0? No. So even that number's no good. So it looks like 4 of the 3 answers I got is the only one that makes sense in the problem. And x equals 4, believe it or not, is the solution to that logarithmic equation. Fourth one I've got on the front of my paper, number 17, looks like this. The log of x plus 5 equals the log of x minus 1 minus the log of x plus 1. Now this time when I, quote, condense my logarithm, I'm going to the right side, and I see a minus in the middle, correct? So the log of m minus the log of n will change to the log of what? Think with me. M over n. Once again, I've got a common log on both sides. The logs cancel. This is understood to be over 1. So once again, I'm cross multiplying. Agreed? To solve this proportion. When I do cross multiply here, careful, you're going to double distribute. Don't you get x squared plus 1x plus 5x plus 5. Make sure that makes sense. Don't just copy without thinking. On the other side of the equal sign, when I take 1 times x minus 1, I get x minus 1. Again, I end up with a quadratic equation. I'm going to take these two guys and shove them over to that side, get everybody over on the left, right? Get it into, quote, standard form. All quadratic equations must get equal to 0. So I've got x squared. Now concentrate. That's 1x plus 5x, which is 6x. But I'm going to minus that x over and get 5x. Now that's a plus 5, and I'm adding over a 1, giving me plus 6 equals 0. Good news, I think this one's going to factor, isn't it? If I take that trinomial and break it into x and x, the signs are the same, both pluses. Can I use 3 and 2, which is going to give me 5? So guys, they're dot connected. I split those apart. Take that guy, set them equal to 0. Take that thing, set it equal to 0. X equals -3 and x equals -2. Unfortunately, think about it. Now, if I plug either one of those into this first equation, they're okay because it doesn't create a log of a negative number. So don't just assume negative answers on a log equation aren't going to work. But notice when you plug either one of those into this log, look at the one I'm pointing at. Do you agree when I take a -3 or a -2 and plug it in for x, that this would end up being the log of -4 or the log of -3, and you can never have a log with a negative number next to it. So technically, we did all that work, had all that fun to find the two best answers, but even they're not going to work. And you would end up writing, oh my gosh, no solution to this problem. It does not have a correct answer. Okay? Finally, the last one I'm going to do on this worksheet, number 19, looks like this. Once again, we start on the left. We see a minus sign. So I'm thinking, again, what? Condensing this by using the quotient rule. So I'm going to write what? The log base 2 of, now since that's the log of m minus the log of n, I'm going to make it the log of m over n. So that's x plus 5 over x minus 2 equals 3. Now there is not a log on both sides, so you cannot cross out the log this time. But notice, we look at this equation, and we do see one log in the problem, don't we? I see one log, so I think of the name Ben, right? I have a, follow the bouncing pen, I have a base, an exponent, and a final number. So I have a base of 2. Over here is my exponent of 3 equals, here's my final number of x plus 5 over x minus 2. Obviously, 2 to the third power is 8, which is understood to be over 1, equals x plus 5 over x plus 2. So now when I cross multiply here, since this is again a proportion, I'm going to get what? 8x plus 16 equals, what's 1 times that value? Of course, it stays x plus 5. I'm now in algebra 1. I'm going to minus the x to the left. So if that's an 8x and I subtract over an x, that gives me 7x equals, this is a 5, but I'm going to what? Subtract over the 16. So when I minus the 16 over, 5 minus 16 is negative 11. Divide by 7. Who would have thunk it? The answer, the only number that actually works in this problem, is negative 11 sevenths. Oh my gosh, how about that? Oh no, wait a minute. If I take a negative 11 sevenths and I go and plug it in there, it's not going to work, is it? Because I would have the log base 2 of negative, what? 11 sevenths minus 2, which is negative 3 4/7. Can you take 2 and raise it to some exponent and have it turn into a negative number? Not possible. Oh my gosh, so once again, we did all that work, got an answer. It's the best answer in the world that would work in this problem, but even it doesn't work. And again, we write no solution. So these can get a little frustrating because sometimes even the answers you think are correct and are the best choices in the world still don't work because they create a log that's negative. So obviously you've got to check your values and make sure they work before you circle the answer with any confidence, okay? All right, guys, your homework. Again, today is Monday, April 20th. So if you could do this right now while this is fresh in your brain and you remember the steps, that's great. Worst case scenario, this is due by tomorrow, Tuesday the 21st. There's a few of you that are starting to fall behind and turn these in at your convenience. That's not how this works. Guys, I've got 111 students to keep track of and emails and papers to grade every day. I need them turned in on a daily basis when they're due. This is not something you do at your leisure on your time schedule at a later date, later in the week and say, oh, here it is. Let's try to keep up. It's 20 minutes a day, not a big deal. Turn these in by tomorrow at noon, Tuesday at noon if you could. 12 to 20 even, that's only 5 problems due for tomorrow. Okay? Great job. Tomorrow we're going to actually show you an application for all of these exponential and logarithmic equations with what's called growth and decay formulas. And it's actually putting this stuff that we're learning to good use in the real world. Okay? We'll see you then. Bye.